What's up, ocean fans? Hi, I'm Rachel Simon, and I am the data engineer on board Nautilus. And this is a behind-the-scenes look through Nautilus. So my role as data engineer is first and foremost making sure that all of the discoveries that we have on Nautilus get recorded and get archived. For the people on board, the cruise ends when we get into port and fly home. But for the data itself, there's a much longer path. So what we're going to do now is take a look through different parts of our rack room, which is the main server area for the entire ship, and also host a lot of scientific instrumentation. This room itself has two parts. So the reason why we have this layout is there's actually two racks right now. This is the forward electronics rack. There's 4 racks of electronics. The reason why the room is laid out like this is for airflow. There is a lot of equipment in here, and all that equipment produces heat. And this is actually a chiller. So this is actually the most important part of the room because all of the heat that's being generated by the electronics in here is handled by this system. So now moving into the actual electronics, this section of the room is predominantly our communication systems, our acoustic systems, and distribution of our basic science navigation. So here, this rack is for our VSAT system. The VSAT is short for Very Small Aperture Terminal. It's a big satellite dish, that big golf ball that you might have seen in Interactions. We predominantly use it for video streaming. That's our main source of internet on board. In this rack, this is actually one of the really important things to watch. This is the actual monitor for the signals that go out on Nautilus Live. So all 3 video streams that I'm sure you all are used to seeing, this is where we actually make sure that we're actually sending video, that we haven't had anything break, fail, anything like that. These last 2 racks behind me are primarily communication systems, but with these 2 racks, this is where we actually start to get back into science. There are 3 really important systems in this rack here. This is the acoustic systems that are permanently installed in the vessel, and we have 3 primary systems. All of these are used when we are doing sonar mapping. The first is, this is a sub-bottom profiler. The sub-bottom profiler is a Knudsen Sharp 3260. Basically what this does is this actually studies the seabed. The second main system that we have is our EM302, which is a multi-beam bathymetric sonar. And what that means is, so this is the computer that runs that system, and a bathymetric sonar means that it's actually giving you the real practical depth of the ocean floor. So this is what's giving us the contour, the shape of the seabed, as well as backscatter, which again gives us some more information on, is this a hard material, is this soft? So in this way, our sub-bottom profiler and our multi-beam do work together. However, this cruise, we've actually been working heavily with one of our newest acoustic systems on board, which is an EC150. It's a combination split beam, kind of like a fisheries sonar, but what's really been relevant this cruise, it has an ADCP, Acoustic Doppler Current Profiler, which is basically an instrument that if you look at the whole water column from surface down to about 180 meters, you can see all of the different current distributions. And finally, this is a really important section of equipment. As you can see, there's quite a lot of wires. Many of our systems that we use are network-based. However, this is an example of serial data distribution. So it is a pretty old school technology, but it's very reliable. It tends to be used a lot in really high precision navigation systems. And this rack is very important because all of these different signals, this is where the vessel actually is. So keep in mind that all of the data we're gathering, everything has to be referenced back to where we are. So for example, if we're mapping, if we're doing ROV operations, if we're deploying instruments, if we don't know exactly where those took place, then we're going to be in a heap of trouble. And so this is the actual signal distribution. All of that information comes from a device called a CPAF 380, which is down in our sonar room. And what that gives us is extremely high precision nav information about exactly where the vessel is on planet Earth. So this has been all of our communication and our acoustic systems. These are things that are connecting us to the world and helping us collect data. What we're about to do in the back row is talk about how that data is archived, processed, and ultimately turned into something that can be delivered to an archive. All right, everyone, and welcome to the back row of the server room. So we have I would say, 4 major components that are happening on the back row. The first and the most basic component, all of this infrastructure here is our shipboard network. There's many different spaces. You can see there is quite a lot of wiring, and it does look like a bit of a bowl of spaghetti. Some of that comes from, we have many different spaces on board that need to get hooked up, but a lot of it comes from we're constantly trying or testing new systems. So there is quite a lot of change that's happening constantly. An example of that is, this is a project that I'm working on for next year. So right now we only have a gigabit per second down to Hercules. This will increase that by a factor of 10. That opens the door for video, or Norbit, which is our high resolution multi-beam sonar that actually goes directly on the vehicle. So it really is going to be a significant capacity and capability expansion for Hercules. So the network itself is, think of it as like kind of like the spinal cord that connects all of the different parts of the ship and the ROVs together. Now, if we think about where the brain would be on the ship, there's basically 2 parts. And the reason is we have, these set of servers here, this is where the majority of the ship's data, a lot of the software that produces things like dive reports, handles image conversion, a lot of those background automated tasks. The majority of the ship's data goes through these. This ship is very data intensive. For a 30-day ROV cruise, we probably generate about 4 terabytes or so of mapping and some video, some imagery. However, this ship is unique in that, because in addition to making sure that we're publishing raw scientific data and findings, we also have a very active and busy in-house production department. And because of that, we actually have 2 separate systems. These servers here host what we call Nautilus FS. And this is our home-built video server called FrankenNAS. This is the machine where all of our really high-quality, broadcast-grade, the ProRes format video is aggregated. And just to give you some examples for just rough orders of magnitude, a 30-day ROV cruise will generate about 50 terabytes of video. And we actually, believe it or not, have to take it off the ship using tapes. This isn't your uncle's 8-track or the VHS that you might have taped The Simpsons on. This is actually very cutting-edge technology. Magnetic tape is, there's a very high data density. So all of the high-quality video from the last 2 cruises, actually last 3 cruises about that, fits onto these 8 tapes here. So the majority of this system is very specific for that really high-quality video data. Everything else goes on these orange drives, which are about 4 terabytes in size. And as you can see, it's a little bit more manageable. The advantage of these is that, you don't need any special hardware like these tape drives to read this data. So we do try and make this as easy to use as possible. You pretty much just plug it in with a regular USB-C cable and you're off to the races. So the majority of what we're talking about here is about aggregating data, bringing it to a single point, backing it up, distributing it out. But there is one final part of the overall system that is important to notice here, and that is these machines right here. These are the multi-beam processing computers. When we are mapping the seafloor, we have the machine on the other side of the room that is actually getting the raw sonar pings and recording them to files. However, the data itself does need some additional post-processing before it becomes a map that we can actually use. Anywhere we go, we're always fighting limitations of time and weather conditions and other logistical issues that come up. So anything we can do to better characterize an area in the time we have available is really going to make these expeditions that much more effective. Thanks for watching, everyone. It has been a real pleasure to invite you guys on this virtual tour of our rack room. It's been really interesting to see. I think this is a very interesting video series because a lot of the behind-the-scenes spaces that don't necessarily normally make it on camera, even though they're behind the scenes, they're absolutely just as important as the ROV control room, the studio that you might see during interactions. And so it's great to have spaces like this get the recognition that they deserve.